All right, 10.7. We're solving radical equations. And the first few on these problems that we're going to do, they're really not too bad at all. We'll move into some a little bit farther on in section 7 that gets tougher. But the first few are pretty straightforward and pretty easy to kind of figure out exactly what they're doing here. They're going to say, now this one, they're doing problems where it's an intro. Okay, and here's your basic rules that you're going to do when you're solving equations, whether it's the intro or the ones that come a little bit later. Now, the intro ones, you're going to have the first step that's pretty much done, but the main thing you're going to do later on when you have some of these like this, you're going to have to get the square root by itself on one side of the equation. Okay, once you've got the square root by itself, which again, with the intro problems and even probably some of the basic problems, it's going to be pretty close to that one. Once you've got the square root by itself, then you're going to square both sides. And the last, it's only 2 steps, but that's your 2 steps. The second part, the last thing, usually that's the easy part. The part where it gets tougher later on is the top part up here when you get the square root by itself. So for this one, most everything's pretty straightforward. This one, the square root's by itself. So then we're just going to square both sides. Okay, and the reason you're going to square both sides is that when you square a square root, they cancel each other out, and you get just whatever is on the inside of the radical, which in this case is x. 10 times 10 is 100, and there you go. Okay, square root of u equals 8. Again, square root's by itself, so really nothing you're going to do here. You're just going to take both sides then and square both sides. And again, when you square the square root, they cancel each other out. This gives you the u. 8 times 8 is 64. Okay, in the intro problems, nothing, they're not tricking you anything here, nothing weird, nothing out of the ordinary. Here you go, it's just a number, square both sides, and then you've got what you need. Okay, where do I go for the next one? You're solving a radical equation. This one says they give you a long definition here, but basically it's this. Again, try to give you the description they give you so that you can go back and kind of check your notes when you're going through these. You're going to solve a radical equation that simplifies to a linear equation. And this is one radical basic. So this is the one where, with the 2 steps we did, the intro problems, they always give you the square root by itself. This one, you're going to have a bunch of stuff around the square root, so you're going to have to start adding and subtracting and multiplying and dividing so that you can eventually get that square root by itself. So this is where you're going to have to do the step in the first work. The last step, when you solve it, where you square root both sides, that part should be really straightforward. So we're going to do -2 plus x plus 5 equals 2. Okay, and for these, going back to what we said first, is that you've got to keep the square root by itself. So this thing is going to get by itself, which means you've got to get rid of a negative 2. How do you get rid of negative 2? Just add 2, right? You add it to the left, you got to add it to the right. So then you've got square root of x plus 5 equals 4. And now you've got the square root by itself. Everything on the outside of the square root's gone, so now you can take this and square both sides. So now you've got square root of x plus 5 squared. And again, when you square the square root, they cancel out. You get just the x plus 5. 4 times 4 is 16. And then from there, you've got to subtract 5 from both sides, so x would equal 11. They ask you to check it. Now, for right now, we're good. We'll tell you when you have to go back and check the answers, because they talk about in there that if there's more than one solution, you got to write it and separate with commas and click no solution. Right now, everything is good. You don't have to worry about checking any answers and going through anything. We'll make you check the answers when you have to check the answers. Right now, you're good. You don't have to worry about those. All right, let's go square root of v plus 13 plus 4 equals 10. Okay, same thing. You've got your square root here. You've got to get rid of this plus 4. So go minus 4. So then you've got square root of v plus 13 equals 6. And once you've got the square root by itself again, just square both sides. So then you get the v plus 13 by itself. When you do 6 squared, that is 36. And again, from there, when you subtract the 13, then you get v is equal to 23. All right, now here's where we got to stay on our toes just one tiny little bit. Okay, so let's say you've got 5 plus square root of 2x minus 7 equals 4. All right, set up the very first beginning still the same way. You're going to subtract 5 from both sides. And then you've got square root of 2x minus 7 equals negative 1. Okay, now flashback to a week or so ago. Any warning bells going off when you see that square root equal to a negative number? There you go. Same thing it was before. If you get square root of something equal to a negative number like we were doing before, when that's a negative number, you can stop right there and just go, all right, that's no solution. And I don't remember exactly where it was when we did that one, but I know there was something we were doing earlier where that popped up. So still the same. Now, the catch is, this number may be negative in the beginning, or in this case, this number was positive. You've got to get it to where the square root is all by itself. If you've got stuff added and subtracted around it, you can't tell anything about it till you get the square root all by itself. Because in the beginning, this number was positive. It was okay. But as soon as we subtracted the 5 to get the square root by itself, now it's a negative number. Now it's no good. Okay, so just kind of realize that may pop up on some of these when you're going through that. Okay, this one is solved blah, 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 everything else, yada, yada, yada. But this one, it says it is advanced. So they can pick it up a notch. Now, it's not too bad because it's still just the one variable part of this one. So even though they say it's advanced, it's really not too bad when you look at it. Okay, so let's say you've got 8 minus 2x equals 6. All right, and this one, there's nothing to do because the square root's already by itself, so you can go ahead and square both sides. Okay, so now you've got 8 minus 2x, 36. The part that makes this one advanced is not necessarily that first part. It's the solving at the end because now you've got to solve this equation. But again, it's not really a hard equation. It's a pretty straightforward equation. You've got 8 minus 2x. You've got to get rid of this 8 first, so you want to subtract 8 from both sides. So that leaves you with a negative 2x equal to 28. Take 28, divide it by negative 2, so your x is negative 14. Now, the answer can be negative, and it's okay, because what happens if you take this negative 14 and plug it back in? When you do a negative times negative, it makes that number a positive. Then you're okay. So, again, the only thing you're worried about is when you check it here, if it's the square root by itself and that equals negative, that's the part you couldn't have. You know, if that had been equals negative 6, you could have stopped right there and said no solution. So the answer itself can be negative, and that's okay, because you'll work it out when you plug the number back in. Okay, so let's go with 4 equals square root of 2u minus 8 plus 3. Alright, one thing to do with this one, you've got the square root that's here, you've got the plus 3 back here, so let's go ahead and subtract 3 from both sides. So you've got 1 equals square root of 2u plus 8. And again, now the square root's all by itself. It's equal to a positive 1, so we're good. It's actually got a solution. So now we get to go back and actually figure out what that solution is. So we're going to square both sides. Okay, 1 squared is still 1. Didn't really change anything there. The square and square root cancel each other out. That is 2u plus 8. So from there, we're going to subtract 8 from both sides. So we got negative 7 equals 2u. And when you divide by 2, you get a fraction answer. And again, if it's a fraction answer, you can just leave it as a fraction as long as it's in simplest terms. Okay, and even though it says advanced, it's really not that advanced. There's not, I mean, yeah, the solving gets a little bit longer, but it's not like super long like in some of the problems before where one went from, intro to basic, that the advanced got 10 times harder. This one stayed pretty close to it here. All right, change of directions on this one. You're still going to solve a radical equation, all of the stuff that I said there. This one, though, you're going to have 2 radicals. Okay, now this one's a little bit easier. Well, I'll say it is. The setup's pretty much the same way. Now, this one, if you get the square roots by themselves, you put one on the left side, one on the right side, which you've already got. Square both sides, just like we did before. So you're going to square the left side and you're going to square the right side. Now, the good thing is when you do that, this one you're just squaring the square root, this one you're squaring the square root. So really all you're going to do is, if you've got one radical equal to another one, just take the square roots off and then just solve the two equations without the square roots. Okay, so from here, I kind of like getting rid of the smaller amount of x's. So let's subtract 2x from both sides. So we've got 3x plus 3 equals 15. We're going to subtract 3 from both sides. So 12 would equal 3x. Take 12 divided by 3 and your x is 4. Okay, and if they give you two square roots, every single time it's going to be the exact same thing. Now, the only way they can do this and make it any kind of at least a little bit tricky, and there's only one thing they can do. Is when they give you the two square roots like they got for this one, they put them all on the same side. Again, all you're going to do for this one is you're going to leave one on one side and you're going to move one to the other side. And the easiest thing to do is take the one that's a minus and just add it so it goes over the other side. So you have the square root of 8y minus 11 equals the square root of 6y minus 9. Now you've got the two square roots on opposite sides of the equal sign, and as long as they're both square roots, you can get rid of the square roots and just solve the 8y minus 11 and the 6y minus 9. It is plus 9, thank you. Wait, yeah, it is. I left it off there, didn't I? Okay, and again, I like getting rid of the small amount of y, so let's subtract the 6y from both sides. Now, if you want to kind of get a little creative and start, speeding up a little bit, if you subtract the 6y's and move them over here, at the same time, you could add the 11y and move them over here. So you can kind of do two steps at the same time. Now, if you don't like that, you don't have to do it that way. So if you move the y's to the left side, you need to move the numbers to the right-hand side. Okay, and that's about as tricky as they can make those. Again, you just put one on one side, put one on the other, and then just take the square roots off and then just solve that equation. Okay, so up to that point, everything has been linear. You get to the end, you've got 8y minus 11, you've got 6y plus 9, so everything basically for that part, and the linear just means you're doing y to the first power. Anyway. Alright, second part of 10.7 here. We're going to solve radical equation, simplifies, but in this case, it's going to simplify to a quadratic. And for this part of it, this is a basic problem. Now, here's the difference with these. Everything up to this point in 10.7 has been linear. When it tells you you're doing a quadratic, that means you have to check your answers. Because when we're getting to the point where this thing is a quadratic, you're going to have two answers. One answer usually works. The second answer, it's 50-50. Sometimes it works, sometimes it doesn't. It just depends on the problem and the answers that you get off this one. Okay, so here you go. You've got square root of 10x minus 21 equals x. And with these problems, it should pretty much give it where you've got the square root already by itself. So we can do like we were doing before. You're going to go ahead and square both sides. The biggest difference on this one is it's not just a number, it's the variable that's over here that you're going to square, and that's what makes this one a quadratic. Is now instead of it just being x, which is what you're going to have on the left hand side, you've got the x squared in there, and that's the quadratic part of it. And if we didn't talk about this one, there's what they call the fundamental theorem of algebra, which says if you solve an equation, the highest power in the equation tells you how many answers you're looking for. So if you start with x squared, you're looking for 2 answers. Okay, now, and for this one, what we're going to do is, the highest variable, in this case the x squared, you always want it to be positive. Or at least for me, it's a lot easier to solve this. So let's move both of these terms from the left-hand side over to the right-hand side. And again, if you want to kind of save a little bit of time, go ahead and do them both at the same time. So on the left-hand side, you'll have a 0. Right-hand side, you've got x squared minus 10x plus 21. Now, and for these being a basic problem, you've got two options. The hard way is you take those numbers, you plug it in the quadratic formula. The easy way is just factor this thing. So what are the factors of 21 that'll get you to 10? Well, it's not going to be 1 and 21. It's going to have to be 3 and 7. And since the b term is negative, the bigger number has to be negative. And if you do a positive divided by negative, that means the other number is also going to be negative. So when you factor this thing, you're looking at x minus 3 and x minus 7. Okay, and once you've factored this thing out, you got to take each parentheses and set it equal to 0. So you've got x equals 3 and you've got x equals 7. Now, and again, with these when you're doing the quadratic, when you get two answers, you have to check because there's a really good chance that one or possibly both of the answers don't work. Probably a better shot that one of them works and one of them does. Most of the time that's the way they go. And when you're going to check these, you have to go back to the original equation. Anything else that you've done where you've squared it, moved stuff around, you've kind of manipulated the equation. So when you're checking these two numbers, always go back to the original problem and check it. Okay, so with x equals 3, we had 10x minus 21 equals x. Okay, again, we'll do the x equals 3, we'll do it in red. So we've got the square root of 10 times 3 minus 21. And then the question is, does that equal 3? Okay, so that's square root of 30 minus 21. Does the square root of 9 equal 3? It does, doesn't it? So yes, it does. So in that case, that one works. So x equals 3 is good. All right, we're going to do the same thing with 7 in this equation. So now it's the square root of 10 times 7. minus 21. Again, the question is, does it equal 7? That's 70 minus 21, which is 49. Does the square root of 49 equal 7? It does. So if both answers work, both answers are good. Let's put that down here. So for that particular problem, you get it where both answers work. And with those problems, you don't really know until you take the numbers and plug them in whether or not those two answers are going to work. All right, for this one, let's go with v equals the square root of square root of 8v plus 9. Okay, and with all these problems, every single one of them, they should give you square root on one side and then the variable on the other side. So all you're going to do is you're going to go back and square both sides. All right, and just to save a little bit of time on these, we'll kind of skip through that part. When you do v squared, that's just v squared. When you square the square root, that's going to go away and leave you with 8v plus 9. All right, and at the same time, we're going to move the 8v from the right to the left. And then again, at the same time, we're going to subtract the 9 to both sides. Or do you want to do it one at a time? Okay, and since we moved the v over, the 8v over, we'll go back and subtract the 9 at the same time. So that now we've got everything to the left-hand side where the v squared is positive, because that's going to make this thing a lot easier when we start trying to solve and factor. Now, and again, the factoring on these should be pretty straightforward because there shouldn't be that many options. The only way you can get a negative 9 to factor, to get the sum equal to a negative 8, is it's got to be 1 and 9. It's just a matter of getting the right sign in the right place. Since this is a negative 8, that sign has to go with a bigger number. So if you do a negative out of a negative, that makes the 1a positive. So when you factor this one, it's v plus 1 and v minus 9. Okay, now you're going to take both of those two and set it equal to 0. And again, the solving should be really easy. All you're going to do is just add or subtract. When you subtract this one, you get v is going to equal negative 1. When you add this one, you're going to get v is equal to 9. But again, you have to go back and check the answers. All right, for the original equation, that was v equals square root of 8v plus 9. Now, hopefully when you do these, we'll do the first one in green. It should kind of jump out at you as to which one of these is going to work and which one isn't. Because when you plug in the negative 1 over here, you get negative 1 equals the square root of 8 times negative 1 plus 9. Can the square root of anything be a negative number? So that one's out. You automatically know that one's out. So if you get a negative answer, there's probably a really good chance with these problems it's not going to work. If you check the 9, does 9 equal the square root of 8 times 9 plus 9? That's a positive answer. If you want to check it just to make sure. That is 72 plus 9, which is 81. Does the square root of 81 equal 9? Yeah, it does. Okay, so for this one, you only have one solution. And that one solution is v equals 9. And the last two objectives in 10.7, we're still solving an equation, but they kind of, these actually get easier. That last one we did was probably the toughest one. This is where they change it up and make it a little bit easier. This one you're solving with an index greater than 2. And this one, they do two types here. This one is type 1, in a minute we'll do type 2. Now, again, the big thing you're looking at on this one is that the index is greater than 2. Now, but don't make the problems really that much harder. That you get the third, and here's one example. You get the third root of u is equal to -4. Now, if this was square root, we were done, right? Now, third roots, it's okay, because third root, you could do a negative times a negative times a negative. That'll make the answer negative, so that one's okay. But if it's square root, it's not a negative number. So, but third roots, it's okay. You can actually get a negative number on these. If it was square root, we squared both sides. If it's third root, you do both sides of the third power. So whatever your index is that's here, that's the power you have to put here. And that way, when you do that one, you do the third root of u to the third power. The third root and the third power cancel each other out. And then we do -4 cubed, that's a -64. Yep. And your type 1 problems that you get on these, they're all going to be pretty straightforward like that. You're not going to have to do any adding and subtracting and moving stuff around. It's pretty much just, okay, here's a number. Let's go fourth root of v is equal to 2. Now again, the numbers won't get too big because if they go to fourth and fifth roots, by the time you do something to the fourth and fifth power, the numbers start to get big. So they're going to be small numbers. They're going to be 2, 3, and 4 because they're just going to get too big and too fast of a hurry. Okay, for that one, again, it's the fourth root, so we're going to do the fourth power to both sides. Okay, fourth power and fourth root cancel, you get v. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay. Now, there's only one other thing they can do for this type of problems. I'll say they give you the sixth root of x equals -1. If the index or the root is even, which is what we've got here, right? Now, if it was square root, we knew it would be a no solution, right? That's the case for any even root. So if the index or the root is even, and it equals a negative, then every single time you get to put no solution. So it doesn't matter if that's the sixth root, the fourth root, the square root, anytime that this index is even and that's a negative number, doesn't matter what it is, if that's an even of any kind, that's always going to be no solution. So it doesn't matter if that, if that was the fourth root of x equals negative 2. That's still no solution. If that was the eighth root of x equals negative 5, it doesn't. If that's an even number for your index that's here, any single time, if that's ever even, it automatically is going to be no solution. Now, and if you flip back up here real quick to the first example, sorry, the second one here, that was the fourth root of v. If it's positive, you're fine. If it's an odd power, that one can be negative, because if you multiply negative times negative times negative, you still get a negative. It's only when that's an even index, because if you multiply a negative number 6 times, it's going to make it positive. So any of those you get if it's negative, and if it's an even root, then it's just no solution. Okay, and then the last thing here in section 7. Here comes the type 2s. Now, and these, you actually have to do a little bit of work to them. It's not just, here's the number, do both sides of the third power, fourth power. This one you actually have to do a little bit of solving here. Alright, so let's do the fourth root of 3x plus 16 plus 7 equals 8. Okay, now, as far as how you go through these, they're exactly the same as the problems we did before. If they give you a fourth root or third root or whatever the root's going to be, you still get that root by itself. So you subtract 7. So you're left with the fourth root of 3x plus 16 equals 1. Okay, now, the same rules here go back to the part here. If you solve these and you get this index all by itself and it's the square root or the fourth root or the sixth root equals, if we had done this one and that had been a negative 1, you'd stop and said no solution. But in this case, we're left with this positive 1. So now we can actually go back through and solve this thing. Alright, now for this one, you'll still solve it just like on the last part. Since it's the fourth root, you're going to take both sides to the fourth power. So you're going to have the fourth root of 3x plus 16 equals 1 to the fourth. Again, if you do the fourth root there, they cancel and you get 3x plus 16. And again, the numbers here are going to have to be small. If you're doing fourth root, it's going to have to be 1s or 2s, maybe a 3. But if you do 1 to the fourth, that's just 1. Alright, subtract 16. X equals negative 15. Divide those two numbers and you get x equals negative 3. All right, now, technically you're supposed to go back and check these answers, but I don't think they're going to be cruel enough that, if you get here, they're going to make you go back and check it and the solution not work. Really, the only time you have to worry about that is that when you solve it here and this thing is x squared, that's when you're really going to have to worry about it. If this thing is just x to the first power, once all the radicals are gone, you should be okay. And yes, thank you. Yeah, negative 5, not negative 3. Okay. And all the other type 2 problems are basically taking the exact same problems that you had before and just tweaking them a little bit. It may be that you're going to have the let's do the fifth root. Let's do the fifth root of 2u minus 4 equals the fifth root of u plus 7. Okay, you've got fifth root on one side, fifth root on the other side. So if they're both fifth roots, you can just get rid of the roots and just do 2u minus 4 equals u plus 7. Same thing with square roots. If you had 2 square roots on opposite sides, you can just get rid of the square roots. If you change it to fifth roots, it's still the same thing because it's still got to be that the 2 inside pieces have to be equal. So from here, we'll subtract the u from both sides. U minus 4 equals 7. Add the 4 back over here, so u would equal 11. Okay. And again, I know they tell you to go back and check your solutions and check for it, but as long as these are all still just u to the first power, once you've gotten rid of the radicals, you're good to go. You shouldn't have to do any checking on these.